Hi everyone, welcome to Flipping Heck Business, Flip Learning for AQA A-Level Business Studies. This is video number 4 in Unit 3, which is Decision Making to Improve Marketing Performance. So what we're going to be looking at today, we're going to be looking at interpreting marketing data. So we're looking at correlation, extrapolation, and confidence intervals. So when we're actually looking at these, then it does link to several other parts of the curriculum. So if we look at marketing data, links to marketing research, sales forecasting, budgeting, so those who are in finance, market analysis, which again is in marketing, and competitor analysis, again part of marketing. So correlation first. Now correlation occurs when there is an apparent relationship between one factor and another. So if you think things like if you increase your advertising, you're going to get more sales. If you have if you decrease your age, then you'll find that your internet use goes up, like as a population, right? So really the way that we measure it is that we'll look at different variables. Now we've got independent variables, so this is a factor that causes the dependent variable to actually change. So if this happens, this will happen. Now the dependent variable is the one that is then influenced by the independent variable. So like if we went back and said, right, well, level of advertising increases, then the number of sales should increase as well. So the advertising would be independent and the dependent would be the sales. So when you actually plot it, we tend to use scatter graphs. And usually it's got the independent variable going, the dependent variable going on the y-axis and the independent going along the x-axis. Now we'll plot a scatter graph usually because we'll have collected key data points and then we'll just input them onto a graph. And then from that we actually draw a line of best fit. Now this basically tries to plot the best straight line that it can between the two variables. So it shows the easiest relationship that is actually occurring. And so the types of correlation is that it might be a positive correlation. So that occurs when there's an upward change in one variable and it increases the value of another. So for example, like we've said already, we've got sales increase might come with income. So if you've got in your market, if there's an increase in the income, well, then they're going to buy more of your product. Negative correlation, so that could exist where there's an independent variable increases in value, the dependent variable actually falls in value. So it could be the number of computer games against age. So the older that you are, then the less computer games that you would actually buy. And then there might be no correlation. So if the correlation is 0, then there is no real relationship. I mean, there is pretty much everything everywhere. So a couple of examples here. So we've got the price of plastic bags in Asda going up actually meant that they needed to order more of their plastic baskets that you would walk around with in the shop. Now that was an actual thing. There should be a link in the comments. Now, basically, when the plastic bag and when the carrier bag charge came in, then what customers were actually doing, some customers anyway, where they were stealing the actual plastic baskets that you walk around the shop with and to take home instead of paying the extra 5p, which is crazy, I know, but this actually cost Asda quite a lot of money. And so we can see that as the prices go up, the more and more people will take advantage of their free baskets and try and walk out with them. So negative correlation would be something along the lines of money spent on medical research. The more money that is spent, then the lower the rates of mortality in the UK. Whereas if we spent less money, then of course those would go up again. And then no correlation would be something like this, where everything's scattered around. And in this case, it's demand for sausage rolls and other savoury pasties and the number of weddings per year in the UK. They don't have anything to do with each other, so therefore they do not correlate. So, I mean, like whether it's strong or weak correlation is, again, looking at that line of best fit. Now, if the correlation is given as an actual value of like -1 and 1, then the higher the figure, the stronger the correlation, regardless of that sign. So it's always a value between those two, and then you're looking for higher. So strong correlation means that there is little room between the data points and the line. So very, very close. So for example, -0.8 is a strong negative correlation, and +0.8 would be a strong positive correlation. Weak correlation means that data points are quite spread out and far away from the line of best fit, but they are still kind of following a trend. So for example, 0.2 is weak negative correlation, plus 0.2 is a weak positive correlation. And then if the data suggests strong correlation, then the relationship might be used to help make marketing predictions as well. So you could actually take those into account when you decide, okay, so what product are we actually going to make? But please remember, just because there seems to be an apparent relationship doesn't mean that there actually is. So if we've got an increase in sales of ice cream, well, the number of shark attacks also seems to go up. Now, that doesn't mean that if we should stop buying ice cream, there will be no shark attacks. It just so happens that they are quite similar in like what actually occurs. Doesn't mean that they actually influence each other. So the next thing that we would actually use for interpreting marketing data is extrapolation. Now, this uses trends established from historical data to forecast the future. So basically, it looks at the moving average. So it will look at like a collection of data. It could be sales, it could be the number of units produced or anything like that. And it will look for their moving average. So, you know, on average, how many sales were made over, say, a quarter, right? And it will then use that point. So moving average is basically calculating the mean or the average of a set of data covering a defined period of time. So for example, a week or a quarter. And when you work out that like sort of average, then it smooths out all these fluctuations, right? It shows an average, it removes any of the extremes, and then it gives you a much clearer sense of like, you know, what is the actual trend that's going on here. So if we look at this as an example, this is taken from Tutor to You, then the blue line here represents like sales per quarter, right? So sales per quarter, and you can see that like it goes up and down, up and down, up and down. Then the red line shows the quarterly moving average. Now, the blue line shows the actual quarterly sales figures, and like I said, they are like quite varying. But that red line is a lot easier to read, and it shows a nice, clearer image. So we can see that there is actual sales growth. Now, once we've gathered this, we can use that extrapolation to just carry it on. So from here, we follow the red line, and we would be able to sort of follow a similar trend going up this way as well. So we can make predictions into the future about what might actually occur. Now, that, you know, isn't necessarily the most reliable of figures, but just by using that average, we can get a guess at what will occur. So the advantages and drawbacks. Advantages is that it is simple. It's very easy to like read. It's quick, it's cheap. You just have to gather the data and then work it out. You don't need too much data either to just, you know, put it into that line. But the disadvantages are that it's unreliable. If there are big fluctuations in the historical data, it could really skewer your results. It assumes that the past trend will continue into the future. So it doesn't really take into account any kind of like new competitors, any new technology that might be coming in, or trends or fashions. And it ignores all the qualitative factors. So like I said, tastes and fashions, it doesn't take that into account. It is just using numerical data. It's just quantitative data. So what we also need to work out then is our confidence intervals and levels. So a confidence interval gives the percentage probability that an estimated range of probable values in fact include the actual value being estimated. Bit of a mouthful. So basically what we're saying here is that once we've gathered loads and loads of data, then we need to go, well, how confident are we that it represents the actual population that we're trying to follow? So in marketing, does it actually represent the whole market, or is it just representation of like the people that we've actually asked? So market research, basically findings, they have a confidence level that gives an indication of how certain they are of the results. So if you were 90% confident that your data is reliable and represents the population as a whole, then that's fairly good. It's not too bad. Usually you're aiming for around 95%. So it could be that, the things that sort of depend on it is the sample size. So for example, if I asked my class of 10, okay, so what is your favorite TV show? Now, would they really represent the whole population of the college or Manchester or the UK? Not particularly. So it's very small and it's very select, and they may all be friends and they might all watch the same thing. They certainly won't watch the same thing their parents do. So I would have to then also have a look at my sampling itself. So is it random, or have I selected people that are going to actually answer the way that I want them to? So if I had a large class size, like if I actually asked like maybe 1,000 people and said, okay, so what is your favorite TV show? And we took that from different people from all different age ranges, all different socioeconomic groups, different like demographic factors, randomly, so that they represented the country, or represented like represented the country as a whole, then we would actually be quite confident that our level would be, a little bit more accurate. Maybe not 90%, but we would certainly be up there. Right? So the more confident that you are, then the better representation, the more accurate you feel that your data actually is. So a few like examples be for quality management. So percentage reliability of machines. So the chance that quality control samples will detect issues. This is something you'll look at when you're looking at operations. Market research, so statistical estimates for sales forecasting. Reliability of data from customer surveys. Any of our market research that we do, how reliable is it? Well, how confident are we that it represents everyone? Any kind of risk management and contingency planning. So again, going back to operations. So what are the risks of the sales forecast not being achieved? What is our scenario for planning if like there are new competitors coming into the market? And then of course, an important one is our budgeting and forecasting. So what is the likely range of revenue of costs based on key assumptions? Are our sales forecasts going to actually support our new product launches? Right? Are we making the right assumption that our sales are going to continue in an upward trend? Does it allow for expansion? Have we got a downward trend? Are we not taking into account any kind of competitors coming into the market? Is that going to get worse? What do we have to do about it? So kind of the final thoughts are that businesses use a variety of tools to analyze marketing data and make forecasts, right? You need to make sure that you have kind of got these. You should be doing these with your teacher. There is Tutor2You have some absolutely amazing calculation books that you can use. So big shout out to them. No one technique though is completely reliable. So you do need to remember that these are just forecasts. These are just ideas. They're putting it together. They're working out averages. They're not going to be 100%. And the key aim of interpreting data is to make reasonable assumptions which support market decision making, right? So it's just there to help you have an idea. It's not there to like just say, well, this has to be the only way that we can do something in our marketing decisions. Okay, thank you very much for watching. If you like this video, please leave a comment below, and video 5 will be following shortly. Make sure that you actually leave a comment, give us a thumbs up, make sure you subscribe as well. Let's see whether we can get this channel really going.